All right, now we're going to go through some sample questions for chapter 14 and 15. I have five questions total that I want to go through. Some of these are similar to what you saw in the PowerPoint, so let's just go ahead and get started. Consumer organization estimates that over a 1 year period, 18% of cars will need to be repaired once, 8% will need repairs twice, and 3% will require 3 or more repairs. So I'm going to type that information out just so we have it, so we know that 18% needs 1 repair. Okay, we know that 8% needs 2 repairs, and we know that 3% needs 3 or more repairs. Okay, so we have that. Now let's go back to the question. What is the probability that a car chosen at random will need no repairs? So no repairs. So if I add all of this up, 18 plus 8 is 26, so that's 29% total, okay? 29% total so far need some sort of repair, okay? And so 29% total need some sort of repair, okay? And I just got that by adding up those. Now to figure out the percentage that don't need any repairs at all, I'm simply going to subtract 100 minus 29. So that's going to be, what, 71% need no repair. So when I put that in Math Excel, okay, notice there's no percent signs in here, so I'm going to write it as a decimal. So 0.71 is the probability that a car will require no repair. Okay, the probability that a car will require no more than 1. So no more than 1 repair. Okay, what does that mean? So no more than 1 repair means 1 or less. Okay, means 1 repair or less. So we know that 18% need 1 repair, and we know that 71% need 0 repairs. Okay, so what's that total? That's going to be 71 plus 18. That's going to be 89%. So that means 89% of cars will need either 0 or 1 repair. That is the answer for part B, 0.89. Okay. The probability that a car will require at least 1 repair. So at least 1 repair. At least 1 repair means 1 or more. So 1 or more are this part up here that we saw earlier, 1 or more, and we had added that up to get 29%. Okay, so we saw that earlier. 29% needs some sort of repair. That's at least 1, so 0.29. Okay, for certain candy, 20% of the pieces are yellow, 20% are red. Whoops, I accidentally got rid of that. My bad. 20% are yellow, 20% are red, 5% are blue, 5% are green, and the rest are brown. If you pick a piece at random, what is the probability that it is brown? So 20 and 20 is 40. That's 45. That's 50% total. That means there's 50% left over. The rest are brown. So that means 0.50, 50% of the candies are brown. The probability that it is yellow or blue. Yellow or blue. So yellow, we know is what? 20%. 20% are yellow. And we know that blue is 5%. So 20% and 5% is 25% total, 0.25. Okay. For a certain candy, 10% of the pieces are yellow, 15% are red, 10% blue, 15% green, and the rest are brown. So let's type that in here. So 10% yellow, 15% red, 10% blue, 15% green, and then the rest are brown. Okay? So 10 plus 15, 15, 10, that's 25. Plus 10 is 35. Plus 15% is 50. So that means 50% is left over. Okay, so that means 50% are brown. Okay, 50% are brown. Okay, so the probability, what is the, if picking is done with replacement, and if you pick 3 pieces in a row, what is the probability that all 3 are brown? So the probability that the first pick is brown is going to be 50%. Okay. The probability that the second pick is brown is also going to be 50%. And the probability that the third pick is brown is also 50%. Why is that probability the same? Because in the question it says if the picking is done with replacements. So we can assume that that probability stays the same. So to find the answer, I am simply going to multiply these three. 0.5, 0.50 times 0.50 times 0.50. Okay, so the answer, the probability that all 3 are brown is 0.125. Okay, next question. The probabilities that an adult man has high blood pressure and or high cholesterol are shown in the table that's over here. What's the probability that a man has both conditions? That means high cholesterol and high blood pressure. That's this one right here. That's just 0.17. Okay. The probability that a man has high blood pressure. So high blood pressure, according to this table, could be one of 2 things. It could be you could have high blood pressure and high cholesterol, but you could also have high blood pressure and okay cholesterol. So to find the probability that a man has high blood pressure, I have to essentially add up this column here. So that's 0.17, which is 17%, plus 0.14, which is 14%. So 17% plus 14% is 31%, or 0.31. Okay. A junk box in your room contains 20 old batteries, 8 of which are totally dead. You start picking batteries one at a time and testing them. Find the probability of each outcome. First of all, notice in this question, it doesn't specify with or without replacement. So we have to assume that this is without replacement, that you pick a battery at random, you test it, you put it off to the side. You pick a battery at random, test it, put it off the side, so on and so forth. So the probability that the first 3 you choose are good. So we know that there are 20 total batteries, and we know that 8 out of those 20 are dead. Well, if 8 out of the 20 are dead, that means 12 out of the 20 are still good. Okay, so I'm going to go into Desmos here. Okay, and this is how you can do the question. Okay, so the probability that the first battery is a good battery is going to be 12 out of 20. Okay, the probability that the second battery is a good battery is not going to be 12 out of 20 again. Because we are assuming without replacement, that's going to bring us down to 11 out of 19. There are now 19 batteries left, of which 11 are good. And then the probability that the third battery is good is going to be 10 out of 18. And the way we find the answer is by multiplying these three fractions. Whoops. These three fractions together, and it gives you the answer. So the probability that the first three you choose are good is this one. It says to round to 3, so that's going to be 0.193. Okay. Excuse me. Find the probability that you have to pick 3 batteries to find one that works. So it's important we first understand what that means. You have to pick 3 until you find one that works. That means that you don't get a good battery until the third try. So if you don't get a good battery until the third try, that means that the first 2 are dead, right? If you don't get a good one until the third, that means the first 2 are dead. So what this is really asking is what's the probability that the first 2 tries you get a dead battery, and then the third try you get a good battery? All right. So we know that 8 out of the 20 are dead. So let's go back to Desmos. The probability that the first one is dead is 8 out of 20. And remember, we need the first 2 to be dead. Okay. So the second one being dead is going to be 7 out of 19. Okay. So we've taken care of the first 2. Now we want the third battery to be a good battery. So my third fraction, okay, I know that in total, I know that there are only 18 batteries left, but if I don't get a good battery until the third try, that means that I still have all my good batteries left by the third one. So that's going to be 12 out of 18. Okay, only 18 batteries are left, but if we assume that the first 2 are bad, then there's 18 left. Of those 18, 12 are still good. So we multiply 8 out of 20 times 7 out of 19 times 12 out of 18. And that gives us, if we round it to 3, that's going to be 0.098. Okay, and that is it for your sample questions for chapter 14 and 15.